Now, another idea that we are going to be using has to do with when we write numbers, something that goes along with those numbers. Let me just ask a few questions, and obviously you can't answer on the video, so I'll make up answers for you. How far is it to your home, wherever you live? Let's just say 32 kilometers. How much does this, I've got some coffee here, how much does this cup weigh? Well, let's say 2 pounds. How long did it take you to get to school or get to work or go somewhere today? Let's say 45 minutes. How tall are you? Well, I don't know how tall you are. I'm about 6'3 3/4", so I'll say 6'3 3/4". How long is this table here? Well, we were just talking about a 2-meter table, so I'll say 2 meters. And how long is this lecture? I'm not sure how long it'll end up, but my classes are usually 1 hour and 15 minutes long, so let's say 75 minutes. Okay, now, all of these numbers, with the exception of one of them, has something that goes along with the numerical quantity. Now, the only exception is this one here, which actually, when we say a height like 6'3 3/4", what we really mean is 6 feet, 3 3/4 inches. Okay, so there we go. Now, these little things that go along with the numerical quantity, these are what we call units. The units that go along with the numerical part. And most of the time, almost always, any time we have a quantity where you quote a numerical part, you are going to have to include the unit along with it. If you don't include the unit, it makes the numerical part impossible to understand, to know what it means. For example, if you were to go to like a fast food restaurant or something, and the person behind the counter says, "Good morning, what can I get for you?" And you said something like, "Oh, good morning, I would like 5, please." What does that mean? 5 what? You have to say what you're talking about. You want 5 drinks or 5 something. You have to tell them 5 what? Whatever you want. That thing you might think of as the unit. For distances, 5 kilometers. For weights, pounds. For time, minutes or hours or seconds or something like that. For this course, we will start out with 3 fundamental units. Next semester, we will find out that we actually have to introduce a 4th fundamental unit. But for now, for this semester, all we will need will be 3 fundamental units. They will be a unit for length, a unit for mass, and a unit for time. All other units that we will use this semester will be made by combinations of these quantities. The system of units that we will use is called the metric system. It's actually a subset of the metric system called the SI, which comes from the Système International System of Units, so the SI system, where the fundamental unit that we will use for length is the meter. The fundamental unit that we will use for mass is the kilogram. And the fundamental unit that we use for time is the second. This is sometimes referred to as the MKS system for meters, kilograms, and seconds. So the SI or the MKS system, these will be the units that we will typically use. Anytime you want to do some calculation, typically it's probably easier to put those units, to convert the units, and we'll talk about unit conversion later on, back into meters, kilograms, and seconds. The one thing, or one of the things, that makes the metric system so easy to use, so much easier than typically the English system with pounds and feet and yards and miles and things like that, what makes the SI system so much easier is being able to go from smaller units to larger units, or larger units to smaller units, by the use of some prefixes that go in front of the unit. Now, for short, the meter we will write as just a lowercase m. Kilogram will be kg, and a second will just be s. So m for meters, kg for kilograms, s for seconds. Now, how can we go from smaller units to larger units? Well, let's take a look. Okay, here we go. So, our basic units that we'll be using, meters, kilograms, seconds. Now, by putting some prefixes on units, what we can do is make them larger values or smaller values. So, for example, if we want to talk about a distance that is longer than 1 meter, we want to talk about 1,000 meters. 1,000 meters, we use the prefix kilo, and 1 kilometer means 1,000 meters. So 1,000 meters we write as 1 kilometer or 1 kilometer. 1 K, K is the prefix for kilo, so kilometer, km, so 1 kilometer. 1,000 is 10 to the 3, so 1 kilometer is 10 to the 3 meters. Now we can put this prefix in front of grams. 1,000 grams is 1 kilogram, or 10 to the 3 grams. And actually the kilogram, that's our fundamental unit for mass. 1,000 seconds is 1 kilosecond, or 10 to the 3 seconds. So 1 ks is 10 to the 3 seconds. We can make larger units than that. So 1,000 kilo is a mega, or 1 capital M. So capital M, lowercase m is a megameter. That would be 1,000 meters, or 10 to the 6th meters. 1,000 mega is a giga. Giga is a capital G. 1 gigameter, 10 to the 9th meters. So a megameter is a million meters. A gigameter is a billion meters. 1,000 giga is 1 tera, and 1 tera, capital T for tera, 10 to the 12th meters. So a mega is a million, giga billion, tera trillion. So 10 to the 6th meters, 10 to the 9th meters, 10 to the 12th meters. We can go smaller. We can define smaller units, so that 1,000th of a meter is a milli. So milli means 1,000. 1,000th of a meter, millimeter. And milli is little m. So little m, millimeter, that's 10 to the minus 3 meters. So 1 meter is 10 to the 3 millimeters. 1,000th of a milli is a micro. Now the symbol that we use for micro is the lowercase Greek letter mu. Kind of looks like a U, but with a little tail in the front. So tail and then a U. 1 micrometer, 10 to the minus 6 meters. 1,000th of a micro is a nano, little n meter. 1,000th of a nano is a pico. 1,000th of a pico is a femto. So we've got 1 meter is 10 to the 3, or 1,000 millimeters. A meter is a million micrometers. A micrometer, also called a micron. So a micron is also a micrometer, another name for it. 1 meter is a billion nanometers, a trillion picometers, quadrillion femtometers. Also a femtometer, also known as a Fermi. These are distances that are commonly used when talking about nuclear sizes. Now, there's also one more very common unit that we will actually be using fairly regularly, and that is a 100th. There are others, like a 10th, 10, 100, but typically the only other unit that we'll commonly use will be 100th. 100th of a meter, that is a centimeter, and that's a lowercase c. So 1 centimeter is 10 to the minus 2 meters, or 1 meter is 10 to the 2 centimeters. And these prefixes can go along with any of our units, seconds, grams, or meters. So we could have a nanosecond, or a picogram, a femtogram, femtosecond, kilogram, kilometer, any of these prefixes. You might have heard some of these in terms of units of storage. For example, with bytes, you could have a byte or a kilobyte, a megabyte, a gigabyte, terabyte, all defined in the same way. So a megabyte is a million bytes, gigabyte, billion bytes, terabytes, trillion bytes. There we go. Now, the quantities that I will expect you to remember, in other words, The ones that I will give you on a quiz and will not define for you, so I expect you to remember these, will be nano, micro, milli, centi, kilo, and mega. So what are these? Remember, nano, 10 to the minus 9th, micro, 10 to the minus 6th, milli, 10 to the minus 3, centi, 10 to the minus 2, the only one that's not a factor of 3, kilo, 10 to the plus 3, mega, 10 to the plus 6. Okay, so there we go. There are the units that we will be using. What we'll do next time is talk about how to convert from one form of a unit to another, how to go from, say, kilometers to micrometers, for example. How to convert from one unit to another. We'll also talk about another type of quantity that's going to be very, very important in describing our motion of things, and those are vectors. So, conversions and vectors next time.